we have three sections to this. So one about balanced forces and unbalanced forces. Then second, free body diagram. Then third one is friction. So then you also see I mapped out the differences. I map out the differences here. So the difference here is that you don't have to do the graphical method for drawing, for adding forces. That's point C. And then you don't have to go deep into Newton's third law. You can have an impression of Newton's third law, touch and go. You don't have to go through in detail what is Newton's, the intricate details of Newton's third law. Then you need to know how to draw free body diagram, but in one dimensional basis, not two dimension or three dimension. Then the rest is exactly the same. So you need to know what is a force. So from primary school to lower sec, this has been repeated over and over again. They say a force is a push or a pull. So that means if you have this standard here, then I exert a force in this direction. That means this is a push. Then if you have same thing, I stand in front and then I hold on to it and then I move forward. Then this is a pull. Then there are certain movements like twisting will be a combination of a push and pull. So there are many examples of this. You can recall it on your own by looking back at your notes from earlier or some other videos that go into the intricate details of what is a push and what is a pull. Then the SI unit of force is Newton, and a force is a vector. What is a vector?
A vector is a quantity that has both numerical magnitude and direction.
Yes. So then what is the opposite? This thing, right?
Yeah.
So this has magnitude only and unit. Then force, the vector is magnitude, direction, and unit. So the effects of a force, so that means is what can a force do? So these are the effects of a force. You can make an object speed up. That means you can kick a ball and then it cause it to speed up. Then you can make an object slow down by pushing it in the opposite direction. Then you change the direction of movement of the object by, say, pushing it on a different direction, in the opposite direction. Many ways to do it. Then you can change the shape of the object, like what we do in camp. We take a hammer and then we hammer the object. Then the shape change, right? Then we can have a stationary object move. How do we do that? We have maybe say a ball that's sitting on the ground. It's not moving, just sit there. Then after that, you can kick it and then you make the stationary ball move. Then the last one is you make the moving object stop. So you stand in front of a moving object and you blocked it, it will stop moving, right? So in fact, this is likely to be an MCQ question. Multiple choice question, you may see. Structured questions, I don't think so. So what are contact forces? So a contact force is when you have the object, two objects, they are in contact. So the objects are touching each other. So when they touch each other, they will exert a force on each other. So it's either push or pull. So they are contact forces. I have a question. Can you name some examples of contact force?
Magnetic.
Magnetic force. Is it a contact force?
Gravitational force.
They say contact force are they have to happen between two objects that are in physical contact. So they must be touching each other.
Gravitational force.
Gravitational force, the force is it's not touching. The gravitational force is the force that the center of the earth acts on the human.
Frictional force.
Yes, frictional force. So that's one. Any more? Any other contact force? Look around you. You can think about it. We'll move. So then there's this thing called non-contact force. So there are two interacting objects are not in physical contact, but they can exert a push or pull, even though they're not touching each other. So whatever you said earlier, gravitational force is a non-contact force.
Magnetic force.
Yes, magnetic force is also not that the objects are not touching each other too. So it's okay. Anything else?
But then the gravitational force things are touching because the gravity is pulling you to the ground.
But is center that means the center of the earth is pulling you down. We are not literally stepping on the center of the earth, right?
Means the gravity comes from the center of the earth.
Yeah. So you have electrostatic force. See? So you have a lot of contact forces. So non-contact force for you is only these three, which is gravitational force, electrical force, and magnetic force. Electrical force is electrostatic force. Okay. So contact force, you name this frictional force. What is tensional force?
When you're pulling something.
So if you hang something or you pull a rubber band, there's this force here in between that rope, then that is tensional force. Then what is normal force?
Normal contact force.
Yeah, so
Is
that
the
means you have
force
this.
that would go towards the ground.
So the thing is on the ground, the normal contact force is the force that the ground exert on the object. This one, normal contact force. Then air
Keep you
resistance.
from going through the ground.
Sorry?
Is the normal contact force keep you from going through the ground.
You won't.
Because the
Yeah,
ground
prevent you from
pushing
going through the ground. Yes.
because the ground pushing you up to keep you above the ground.
Yeah. If not everything on the table will just drop
Not
towards the
everything
center.
that go through the table.
Go through a table. Then after that, it depends on which floor you stay at. Because what happens is the object is being pulled down by gravity. So if you put the computer on the table and there's no normal contact force, it will just go through the table. And then after that, you land on the ground. And I mean, depend on which floor you stay at. If you're not staying on the ground floor, it will continue to go through and then go downstairs. It's quite scary looking, imagining what is air resistance?
When someone's skydiving, there's air pushing you up.
Yes, that's
When
air
you open the
resistance.
parachute, there's air
Yeah.
that makes the parachute go up.
Yes. Then applied force is just the force that I apply on an object, like I push the table, then that is the contact force that I apply on the table. So you know all this.